So this is Johnny. I'd like to talk a little bit about subtraction today. I was working abroad at an international school in Istanbul, Turkey, and working with parents, and I presented this problem to them. What came about was some interesting math, and one of the things that came up was the Austrian method. So today I'm going to be looking at 256 minus 148 in a number of ways, including that special way. Let's work out this problem using the traditional algorithm using regrouping. 256 minus 148. Now, in the traditional algorithm, we ask ourselves some questions. We look in the ones column first, and we say, can 6 take away 8? We say, no, that's not possible. So something will have to happen for the 6 in order to take away the 8. Well, we do notice that there are 5 tens in 256. Maybe we can take one of those tens, leaving 4 tens, and give that 10 to the 6. And now we have 16. Now we can subtract. 16 minus 8 is 8. 4 tens minus 4 tens is no tens. And 2 hundreds minus 1 100 is 1 100. That sounds all good. Now there's some assumptions that are built into this. One is that subtraction has to start in the right-hand side and move to the left. That's not necessarily so. The other assumption that's brought into it is that we can't talk about 6 taking away 8 or 6 minus 8 as a possibility. When we say 6 can't take away 8, we're not actually saying something that's mathematically true. 6 can take away 8. We just end up with a negative number. And there's things we could do with that and think about in subtraction that we avoid with younger children. Teachers will often introduce this algorithm using base 10 mats and base 10 blocks and bars. So let's take a look at that. So the columns are going to represent the place value, and we'll label them. This column will have the ones, this column will be the tens, and this column will be the hundreds. And holding on to that, we can describe 256 as 2 100s, or 2 flats, 5 tens, or 5 rods, and 6 ones, or 6 units. We can describe 148 as 1 100, or 1 flat, 4 tens, or 4 rods, and 8 ones, or 8 units. In order to use this model to show the algorithm, we will need to do some regrouping. Because again, if we look at what we have right now, we can see that 6 ones can't take away 8 ones if we're going to think about it that way. So we need to do some regrouping. What we're going to do is take one of the tens from 256 and reconstitute it into 10 ones, or 10 units. So this is going to become 10 units. 6, 7, 8, 9, and 10. Now we can ask the question again. Can this lot of ones take away this lot of ones? And it can. 16 ones minus 8 ones will give us 8. And if we look in the tens column, 4 tens minus 4 tens will leave us with no tens. And in the hundreds column, 2 hundreds minus 1 100 leaves us with 1 100. The base 10 blocks are a great way to introduce this algorithm and help us think about regrouping and subtraction. But there's another way to think about it. Let's take 256 minus 148 and represent it differently. Let's take 256 and describe it using the distributive property. 256 is the same as 200 plus 50 plus 6. And 148 is the same as 100 plus 40 plus 8. Now, we can subtract these. And one of the things about this is that we don't have to start on the right hand side and move to the left. We could start 200 minus 100, 50 minus 40, then you get 6 minus 8. It gives us our negative 2, and that could work out. But let's think about this a little differently. If we were using the traditional algorithm, we still have the problem of 6 can't take away 8. So we can think about reconstituting the 50 into 40, and the 6 becomes 16. So everything in this manner maps onto these other two versions of the subtraction. So let me rewrite this, and we can see how this all connects. 200 plus 40 plus 6 looks like 200 plus 40 plus 16 now. So this becomes this. And our 100 plus 40 plus 8, 100 plus 40 plus 8 becomes the same as well. What's nice about this is that you can see in these columns on the base 10 mat, they're the same thing. You can see how the regrouping worked. So originally we had 200 plus 50 plus 6. Now we've rewritten it using the distributive property as 200 plus 40 plus 16. And if we do the subtraction, 16 minus 8 gives us 8. 40 minus 40 leaves us with 0. And 200 minus 100 leaves us with 100. And if we add these together, we come back to our 108. So my suggestion is, working with the base 10 mats is great. Showing the students how to use the traditional algorithm with just numbers, like the way I started, is wonderful too. But think about the possibilities of using the distributive property to connect it all together. Now there's a different approach I'd like to share with you. It's called the Austrian Method. So let's take a look at the Austrian Method. First, let's rewrite the problem. 256 minus 148. And we want to keep in mind that this top number is the minuend, and this bottom number is the subtrahend. It'll help us keep straight what we're doing as I describe this. And of course, the minuend minus the subtrahend gives us the difference. Okay, so that's all good. Now looking at the problem the way we did with the traditional algorithm, we'll see that 6 can't quite take away 8. We know that's not quite true, but let's hold on to that for a moment. What I'm going to do is make that 6 into 16. Now you're going to ask, well, how can you do that? Well, I have to do something to make it fair. In the traditional algorithm, I regrouped from the 10s to give one 10 over to the 6 to make 16. In the Austrian method, we do something different. I've added 10 to the minuend. To be fair, because we have to be fair in math, I also have to add 10 to the subtrahend. So while I've made the 6 into 16, I'm making the 4 10s down here into 5 10s. That's great. Now let's do the subtraction. 16 minus 8 will give us our 8. 5 10s minus 5 10s will leave us with no 10s. And 200s minus 1 100 will leave us with 1 100. So we end up with 108 again. So we did well with this. The Austrian method works out just fine. How does this work? Well, think about it this way. If we put this 10 in the minuend, and then we put a 10 in the subtrahend, remember that this 10 at the top will subtract out the 10 at the bottom. So it leaves no difference. It doesn't affect the problem at all. So adding whatever you want to the minuend, as long as you add the same amount to the subtrahend, will have no effect. So let me show you what this looks like on a number line. So I'm using an open number line, and we can put our numbers here. So let's go ahead and put 256 here, our original number, and 148 here. That's probably okay. Now what we're looking for is the difference between these two numbers. Now with the Austrian method, what we're doing is we're adding 10 to each of them and essentially making this 256 into 200 plus 50 plus 16. We've added 10 here. With 148, we've added 10 to this as well, and we've made it into 158. Now if we look at the difference between these, the 158 and the 200 plus 50 plus 16, it's the same as the difference between 148 and 256. We shifted this over by 10, we shifted this over by 10, and the difference between those numbers remains the same. Let's do one more problem with the Austrian method, a more difficult problem. Our minuend this time will be 307, and our subtrahend will be 158. It's a little different than the last problem. You'll see why. Let's look at the ones column. 7 ones minus 8 ones. We've talked about that before. What are we going to do about it? Well, let's just make the 7 to 17. So I've added 10. I will have to add 10 also to the subtrahend. Since I've added 10 to the minuend, let's give 10 to the subtrahend. Instead of 5 tens, this will now be 6 tens. Everything's great now, right? So we've added 10 to the minuend, 10 to the subtrahend, and we have a problem we can work now. Let's try it out. 17, or 17 ones minus 8 ones, will leave us with 9. We go to the tens column, 0 tens minus 6 tens. We're in trouble again. What can we do about this? Well, using the rules in the Austrian method, I can add again to the minuend. I will make this 0 into 10 tens. If I'm going to do that, I also need to add 100 to the subtrahend, and so this 100 becomes 2 100s. Now let's try the subtraction. 10 tens minus 6 tens gives us 4 tens. 3 100s minus 2 100s gives us 1 100, 149. And again, if we look at how we've added over here, this 10 will subtract out this 10, this 100 will subtract out this 100, and there's no effect in the difference. I've always been amused by the Austrian method. I was working with parents at an international school in Germany, and I shared this subtraction method along with some others, and 3 moms stood up and were quite happy to tell me that this was the way that you're supposed to do subtraction, and they all happened to be Austrian. Now, this Austrian method is used by people around the world. I've had parents from Spain and other places share that this is the way you're supposed to do subtraction. And I've had students in my work in California, students who are becoming teachers, tell me that this is the way they learned how to do subtraction in Mexico. So we may think of the traditional method as the way you're supposed to do subtraction with the regrouping, but it's not a rule. There are other approaches. Now let's look at 256 minus 148 a different way. And this particular way I'm going to call the additive approach. Let's use a number line to help us understand how to use addition to do subtraction problems. So let's start with an open line, an open number line, and let's add a few things. We'll start with 0. We'll say 148 is about here. And we'll say 256 is about here. We are remembering that 256 is the minuend, and 148 is the subtrahend. The reason we care is that we're looking for the difference between the two. Now, a lot of times when we do subtraction, we talk about how much is left over. Thinking about difference is a much more useful way to think about what's happening in some ways. The difference tells us how far apart the two numbers are. How much space is there between 148 and 256? And that's where addition comes in. So if we think about addition, we can say, well, I need to add some numbers to 148 to get me to 256. So let's do that. I could add 2 to 148 to take me to 150. I could add 100 more to that 150 to take me to 250. And then I could add 6 more to get me to 256. So the space between 148 is 2 and 100 more and 6 more. So the difference between 256 and 148 is 2 plus 100 plus 6. And when we add that all together, we get our 108. So when you have a problem like 256 minus 148, instead of asking how much is left over after we take away 148 from 256, we can say, how much do we need to add to 148? So 148 plus something will take us to 256. This is a great way to teach kids about how addition and subtraction are reciprocal. So let's try one other method. We'll call this one compensation. And as I work through compensation, think about how it's connected to the Austrian method. So I'm looking at the numbers 256 and 148. What I like about 148 is this 8. I know that I can round this number up. So I could take 256 minus 148 and remake the problem into something with 150, because 150 is a nice round number. We like our tens. So I've added 2 to the 148 to make 150. Now, because I've added 2 to the 148 to make that nice round 150, I need to add 2 to the 256. And this will take us to 258. And if I subtract these out, you can see 8 taking away 0, quite easy. I have 8, 5 tens minus 5 tens, no tens, and 2 hundreds minus 1 100, 108. So compensation works like the Austrian method in that you can round a number, bend a number, shape a number to a friendly number, as long as you do take into account how you've changed it and do the same to the top number. So I have one more surprise for you. Some big numbers with zeros. And think about how this compensation method works with a little bit of a twist. Now I want to share with you something amusing. Take a look at these two problems and think about the traditional algorithm for subtraction with regrouping. And you know that it looks ugly. So let's take a look at that. 2000 minus 787. Using the traditional algorithm, the zeros can't take away the numbers in the subtrahend. So we're going to regroup. We'll make this one 2,000 into 1,000. We're going to give one of those to the hundreds place, making 10 hundreds, which is 1,000 also. But we need some of those for the next number, so let's make this 9 hundreds and give 100 over to the hundreds place. And all of a sudden we have 100 here. But that's not sufficient, so we need to make this into 90 and make ourselves a 10 here to be able to subtract that 7. And we end up with 10 minus 7 is 3, 9 tens minus 8 tens is 110, 9 hundreds minus 7 hundreds is 2 hundreds, and then 1,000 minus no thousands is 1,000. Now let's do this differently, and let's use the Austrian surprise. All right? So I'm rewriting the problem, 2,000 minus 787. I don't like 2,000. What I'm going to do is I'm going to subtract 1 from the minuend, and I will subtract 1 from the subtrahend. So let's rewrite the problem using that now. Now we have 1,999 minus 786. What does that look like for us? Well, 9 minus 6 is 3. 9 minus 8, or 9 tens minus 8 tens, gives us 110. 9 hundreds minus 7 hundreds, 2 hundreds. And 1,000 minus no thousands leaves us with just 1. And you can see that the same thing in the Austrian method. Whatever you do to the minuend, you do to the subtrahend. All is fair. All right? So if we think about the number line, we shifted 2,000 to 1,999 by just moving it over 1. And we move the 787 to 786 by moving over just 1, and the difference remains the same. So let's think about this other problem and how we might use this variation on the Austrian method to solve it. What we have is 3 million minus 287,598. Let's go ahead and subtract 1 from the minuend and subtract 1 from the subtrahend to be fair. And let's rewrite the problem. Now we have 2,999,999, and we have 287,597. Now if we subtract this, 9 minus 7 is 2, 9 tens minus 9 tens leaves us with no tens, 9 hundreds minus 5 hundreds leaves us with 4 hundreds, 9 thousands minus 7 thousands leaves us with 2,000, 9 10,000s minus 8 10,000s leaves us with 1 10,000, 9 100,000s minus 200,000s leaves us with 700,000, and 2 millions minus no millions leaves us with 2. So in this problem you can see the virtue of the Austrian approach, where you're adding or subtracting from the minuend or the subtrahend to make better problems for yourself. I hope you've enjoyed this journey through subtraction. Hope I've given you some things to think about that might help your work with kids go better and help us all think about subtraction in more interesting and useful ways.